Okay guys, so here is a test review video, and I'm trying my best to make this as clear as I can, but I mean, that's why you got the test review sitting in front of you, hopefully, or at least on another screen if you're watching this video. So I'm just going to go from beginning to end. This first one starts off with x plus 11 is greater than 16. So if I'm going to graph this, realize it's just one dimensional. It's just one variable, and that's why we're just graphing it on a one-dimensional line here. Okay, so this is just all I need to do really on all of these is solve for x. So we have x plus 11 greater than 16. To solve for x, I'm going to subtract 11 from both sides. Plus 11 minus 11 cancel. The x is what comes down. Greater than 16 minus 11 is 5. Okay? And if you don't understand how I solve, or if your problem is always just solving, then look up a video on YouTube, right? On just solving for a variable, or solving for y, or solving for a variable would be fine. Okay, so x is greater than 5. So now I'm looking at all my answer choices. This is the correct answer, and this is y. So notice at 5, it's an open dot. Remember, I talked about an open dot is when it's just strictly greater than. If it's greater than or equal to, meaning that it has that line below it, that's a closed dot. So this is an open dot, and it's going to the right, because what the graph is showing you is where all the possible answers for x reside. So it's saying x is bigger than 5. Well, here's 5, and here's where all the bigger numbers are. Okay, so x is bigger than 5. So this is actually C. All right. I'm going to go ahead. Maybe I'll just work through the odds or something on this. All right, so here's number 3. Number 3 is x plus 2 less than or equal to negative 3. So solve this for x, minus 2, minus 2. Plus 2 and minus 2 cancel out, so x is by itself. That's what you wanted. That's what it means to solve for x. Get x by itself on one side of the equation. Negative 3 and negative 2 combined is negative 5. So there's my answer. So this is x is less than or equal to negative 5. So I'm looking at all my answer choices. Here's one where it's at negative 5. It should be a closed dot because it's less than or equal to. So this one actually has the line on the bottom. And it's saying that x is less than or equal to negative 5. So here's negative 5. If x is less than negative 5, of course it would be anything to the left, where all the smaller numbers reside. So it's telling you that x is less than negative 5. So our graph representing all the possible answers for x is at negative 5 and smaller, because x is less than negative 5. Okay. Number 5. I'll just leave that there. Okay. So this one is A. Number 5 is x minus 1 is less than negative 7. So again, solve. Add 1, minus 1 plus 1 cancel. X is less than negative 7 plus 1 is negative 6. So I'm looking at my graphs. Which one shows x is less than negative 6? So here's an open dot at negative 6. And the arrow pointing to the left because x is less than negative 6. So remember, if you also have trouble with, less than or greater than, oftentimes I don't even know those words. I just remember what somebody told me at one point, that mouth is always eating whichever number is bigger. So this is saying that negative 6 is bigger than the x. Okay, so x is smaller than negative 6. So when I look at my graph, I make sure I graph everything that's smaller than negative 6. All right, so moving on. And this first part, guys, this is the easiest part of the test. All of this is really pretty simple and straightforward. So that is solving by adding or subtracting. So here's another one, except this time I'm not going to match it to a graph. I'm actually going to graph it. So here's number 7. 7 is t plus 9 is less than 8. So solve it for t by subtracting 9. Plus 9 minus 9 cancel. T is less than 8 minus 9 is negative 1. So now to graph this, notice it's strictly less than, so it's an open dot at negative 1, and t is less than, it's smaller than, so that negative 1 is bigger. Remember, the mouth is eating the negative 1, so negative 1 is bigger than t. So I'm going to graph anything that's smaller than negative 1 that could represent t. Anything to the left of negative 1 represents t, and that's it. Let's do this one. This one, number 9, is w minus 1 is less than 4. W minus 1 is less than 4. So I'm going to now add 1 to both sides. Minus 1 plus 1 cancels. So W is less than 4 plus 1 is 5. So in your mind, hopefully you're thinking something along the lines of, okay, that's going to be an open dot. It's going to be at 5. Open dot at 5. Now W is smaller than 5. This is saying that 5 is bigger than W. So all my possible answers for W are smaller than 5. All right, so we're going to keep going on with this. All right, scroll down some. So I'm going to do 1, 3, and 5 on this section. So right here, what it's saying is negative 4 times n is greater than or equal to 5. And I'm going to match it with its corresponding statement. So if you can't see it, it's negative 4n greater than or equal to 5. Okay, so I'm looking for something that says something like negative 4n. So negative 4 times a number. Okay, that's it. Negative 4 times a number is less than 5. This one is actually saying that negative 4 times a number is bigger. Remember that mouth is eating the bigger number. Is bigger than 5. So it's not that one. Negative 4 times a number is no less than 5. So that makes sense. So think about what it means to be no less than. Okay? So if I tell you I have in my pocket no less than $6, that means I don't have anything smaller than $6 in my pocket. I have like either I could have 6 because I have no less than 6. So I could have 6, I could have 7, 8, but more than likely something bigger. So right here it's negative 4n is no less than 5. So it could equal 5. That's what that line is on the bottom showing you. But more than likely it's greater than 5. All right? So this one is D. You just got to think about the words on these. Okay. Number 3 is 4n is less than or equal to 5. So that's that back up to this one. Is less than 5. Nope, it's not actually. So number 3, 4n less than or equal to 5, if you can't see it. So it's not A actually. So let's see. 4 times a number is at most 5. It's this one. See, when you say the words is at most, that means it could equal 5, but that's only at its biggest. It could equal 5. More than likely, it's going to be something smaller than 5. If something is at most 5, it's going to be smaller than or equal to 5. So this one is E. So 4n is less than or equal to 5. 4 times a number is at most 5. Okay, that works. And then number 5, lastly, I'm going to go ahead and erase this because to me it just kind of seems messy. Going to keep going with this though. Number 5 is 4 times a number is. There's no equals to. It is less than 5. Just straight up. It's less than 5. It can't equal it. Okay, so I'm looking for 4 times a number is fewer than 5. So notice in that phrase, is fewer than, there's no room for saying it could equal 5. No, it's straight up fewer than 5. All right, so that's this one right here. 4 times a number is less than 5. Okay, so this is going to be C. And if you can't see it, what I'm talking about is 4 times a number is less than 5. That's what it was written there. Okay, going on to the next page. Okay, so solve each inequality and check your solution. All right, so to check your solution, well, let's just solve them. So this is 14g. Number 7 is 14g is greater than 56. So if I'm going to solve for g and I want g by itself, I'm going to divide by 14 because this is 14 times g. So I'm not going to subtract it. I would subtract 14 if I was adding 14 to this side, but I'm not. I'm multiplying 14 to g, so I'm going to, if I'm going to get rid of it, I have to do the opposite, which is divide by 14. 14 divided by 14 is 1g, and that's greater than 56 divided by 14, which is 4. There's my answer. Now, if I'm going to check this, what I would do is pick, this is saying g is bigger than 4, so pick some number that's bigger than 4. Let's say 5. I would take 5. I would plug it into this for g, so 14 times 5 is greater than 56. And I'd multiply this out, and I'd find out that, yes, 70 is greater than 56. So it is true. All right, that's how you would check it. That's the checking aspect. But technically on the test, I'm not going to make you check it. That's just a good way to make sure you get the right answer, is by checking your answers. Okay. On this one, this is 20b is greater than or equal to negative 120. So to solve for b, I'm going to divide by 20. So b is greater than or equal to negative 6. Now you can check that by picking any number that's bigger than negative 6, like 0, and plugging it into this. 0 is bigger than negative 6, so let's see real quick. If I plug 0 in here, that would be 20 times 0, which is 0, is greater than or equal to negative 120. And that is a true statement. So there's just another example of checking your work. Number 11, and then I'm going to actually, well, I'll do number 11 and 13. So number 11, negative 15p less than or equal to negative 90. So if I'm going to solve this, I need to get rid of that negative 15 times p. So notice the wording that I chose to use there. This is negative 15 times p. So to get rid of negative 15 times p, I need to divide by negative 15. I don't want to add 15. Okay? So I want to divide by negative 15 because that's what's the opposite of what's happening here. Right? So negative 15 divided by negative 15 is 1. So I have 1p. Ooh, and I almost messed up. Okay, let me go ahead and continue on with this. Negative 90 divided by negative 15 is positive 6. Now, remember what I told you guys, and this is what I almost did wrong. You might almost do it wrong on the test, so be careful. When you divide by a negative, your sign needs to change directions. Okay, so that was wrong up until this point. Now it's right. So notice my sign was facing to the right. Now because I divided by a negative, it needs to change and face to the left. So let me say that one more time. If I ever divide or multiply by a negative, change the direction of your sign. Okay, number 13. Number 13 is Number 13 is a divided by 9 is greater than or equal to negative 15. So if I'm going to get rid of divided by 9, I need to do the opposite, which is multiply by 9 on both sides. These cancel. So a is greater than or equal to negative 15 times 9. What is that? Negative 135. A is greater than or equal to negative 135. All right. So that's it for that little section. Let's go on to the next one. And I'm probably going to start running out of space, so I'm going to have to write over the top of these. All right, so I'm going to do number 3 on this section. Number 3 says, I'm just going to write right over the top of this. Negative 2b. I'm going to check the video real quick after I write this out to make sure you guys can see when I write over the top of it. So if you're going to solve for b, you need to subtract 4 from both sides first. Let me backtrack a little bit. So remember I talked about if you're solving a multi-step inequality or equation, it does matter the order in which you get rid of these numbers. So for example, for solving for b, we need to get rid of 4 and that negative 2. And it matters the order in which we do that. So remember I talked about you want to do the order of operations. But when you're solving, you want to do it backwards. So you want to start with whatever's being added or subtracted. Okay, and notice on this side, we have a plus 4. That negative 2 is being multiplied by b. So we don't get to get rid of that negative 2 until we get up to multiplication. Right now, we want to get rid of that plus 4 because that's addition. That's the first thing we want to do. And that's why we do that first. So we have negative 2b comes down, is greater than negative 6 minus 4 is negative 10. Now I can get rid of negative 2 times b because that's multiplication. So I'm going to divide by negative 2. Remember I talked about when I divide or multiply by a negative, so I have 1b, the sign changes directions. 1b is less than 5. Now let me see what the video looks like when I'm writing over the top of this stuff. Oh, it looks fine. Okay. And I apologize for writing over the top of it, but right now I don't really have a better way of doing this. And I could figure it out, but it'd take me a little while to set up. So I'm just going to keep going with this. Let's see. Number 5. All right. Number 5 says, and I'm talking about this one right here. It says d divided by 2 minus 1 is greater than or equal to 3. So I'm going to begin, again, by getting rid of whatever's added or subtracted, so that's that, plus 1, get rid of that. D divided by 2 greater than or equal to 4. So I just talked about the order in which you do things. You have to keep that order. Then I'm going to get rid of division by multiplying by 2. Multiply by 2. 2 divided by 2 is just 1. D is greater than or equal to 4 times 2 is 8. Notice when I multiply by 2 or divide by a positive, the sign doesn't change directions. Okay, that's that one. Number 7. 7 looks like one that would kind of give you guys a hard time, so this will be a good one to pay attention to. All right, number 7. Number 7 is negative t divided by 5 plus 7 is greater than negative 4. All right, so if I'm solving for this, again, you want to get rid of the addition right here first. Those cancel. Negative t divided by 5 is greater than negative 11. Okay, so to get rid of this, you can either look at this negative being on top, or you can put it on bottom, whichever way you want to look at it, okay? That's the deal when you're working out something like this with a negative in front. If it doesn't specify, whether it's on top or bottom, honestly, it never really matters. But if it doesn't specify especially, you can put it on either top or bottom. I'm going to put it on bottom, okay? So I can get rid of that negative 5 all in one step. So right now it's t divided by negative 5. I'm going to multiply by negative 5, multiply by negative 5 on both sides. This cancels. Okay, so t, now remember, I multiplied by negative, so my sign changes directions. Negative 11 times negative 5 is positive 55. Okay. Oops. That wasn't good. Okay, so that was number 7. Okay, let's see what else we can do here. I'll go ahead and do number 3, 5, and 7 off of this section really quick. I need to start working a little bit quicker. So, here we go with a little bit less explanation. Just remember, everything I'm doing here has an order to it. And it's the inverse order of operations. I'll just write that to the right side. This is the order I'm doing everything. Starting with addition and subtraction, moving up. Multiplication, division, exponents, parentheses. There's really not much of this on this test. So I'm going to get rid of that minus 5. Notice this has a minus 5 here. So I'm going to add, get rid of, drop down the negative t divided by 6, greater than or equal to negative 4. I'm going to take that negative, I'm going to put it on the bottom, okay, and get rid of both things at once. The negative 6, I'm going to multiply by. And the reason I'm multiplying by negative 6 is because I was dividing by negative 6 a second ago. So I'm doing the opposite. Sign changes directions. Negative 4 times negative 6 is positive 24. All right. Doing number 5. Number 5 is 13 greater than 2 over 3a minus 1. Okay, so I'm going to start off by if I'm solving for a, I need to get rid of 2/3 and that minus 1. Start off with the minus 1. Opposite of minus 1 is plus 1. And this is going to be 14 is greater than 2 over 3a. Now, if I want to get rid of 2 over 3, I can do it in 2 steps, or I can do it in 1 step. To do it in 2 steps, you would first multiply by 3 to get rid of the divide by 3 part, and then divide by 2. Or you can just multiply by 3 halves, the reciprocal. And that's what I'm going to do here just to save some time. So 3 halves cancels with 2/3. So a comes down. And then 14, I don't know what it is. So 14 divided by 2 is 7. 7 times 3 is 21. So that would be your answer. Okay? If you didn't understand what I just did, you can always type it into a calculator. 14 times 3 halves. 3 halves is just 1.5. What I actually did, though, is I did 14, and I divided by 2 in my head, that's 7, then I multiplied by 3, and that's 21. All right, That was number 5. Here is lastly number 7. Number 7 is right here. So 3f minus 10 divided by 5 is greater than 7. So I'm going to start by multiplying by 5. Okay. Now the reason you do that, this is tricky. Okay. So the 3f and the minus 10 cannot be released until you get rid of, notice they're all grouped together. Okay, you might as well say that they're in a parentheses because they're grouped together and they're all over, they're in the numerator of this 5. They're all over 5. Okay, so until I get rid of that 5, I cannot get rid of that minus 10 or the 3. So I'm going to start by getting rid of that 5. Multiply by 5 on each side. Those cancel. So 3f minus 10 is what comes down. 7 times 5 is 35. Okay, I'm going to add 10 to both sides. So without even writing it, 35 plus 10 is 45. Okay, I'm going to divide by 3 on both sides because it's 3 times f. So I'm going to divide by 3. F is greater than 15. Okay. All right, let's keep going. Man, this is a long video. I didn't realize how many problems. Maybe I'll stop working just the odds or something because this is taking a while. Okay. Compound inequality. So remember, a compound inequality has 2 limits on it. Let's see how long this video has been going. 21 minutes. All right. So a compound inequality has 2 limits on it. And that's why you see in number 1 right here, it says graph pretty much -4 is less than or equal to n, which is less than or equal to 1. So in this situation, it's really easy to see. N is going to be bigger than -4, but less than 1. So I'm going to just put a mark at +1, put a mark at -4. Notice they're closed dots because it has the equal to part. And that's where n is. It's in between those two. Okay? N is bigger than -4, but n is less than -1. And you can see it in 2 separate parts. So what I mean by 2 separate parts is like this. N is less than -1. So that's this. Here's +1. N is less than that. Other part is n is greater than -4. So here's -4, n is greater than that. So it's in between. All right. I'm going to go ahead and do 3, I guess. So g is less than, so this says g is less than -3, or g is greater than or equal to +4. So let's say +4 is here, okay, and I'm just estimating -3 is there. That's not probably accurate, but close enough. G is greater than or equal to, so that's a closed dot, and greater than or equal to 4. So 4, greater than 4, okay, so it's in that direction. G is less than -3. So here's -3, open dot because it's strictly less than -3. So all a compound inequality is just 2 inequalities in 1. All right. So it's just like those inequalities we did at the very beginning of this video, except now you're just doing 2 on 1 graph. Number 5. Number 5 is write a compound inequality for each group. Okay, so this one, I think they look like closed dots, both of them, closed dots. This one is saying it's less than -3, so I need to say x is less than -3. Notice I just put strictly less than, no equals to, no equal to because it was a, it's a closed dot, so it does need an equal to. This one is bigger than 3, so x is bigger than or equal to, because it's a closed dot, +3. So x is less than or equal to -3, going in that way, or x is bigger than or equal to +3. All right. This one, notice x is between 0 and 5. So what this graph looks like is it has 0 right here with a solid dot, goes over to 5 with an open dot. I'm going to write this out in 2 ways. Look, I could write x is bigger than or equal to 0 and x is less than 5. I could write it like that, or I could just say x is bigger than or equal to 0 or less than 5. So notice it's between 0 and 5, and I just wrote it as one big inequality. Either way would work fine. And guys, I realize I'm just rushing through this video, but if you need further help, you can search all of this stuff on YouTube. So for example, solve each compound inequality. On YouTube, type in solving compound inequalities, and you'll get plenty of videos. All right, I'm going to do 9 and 11. So let's start off with 9. 9 starts off and it says k minus 3 is less than negative 7, or k plus 5 is greater than or equal to 8. So you need to solve these separately. So solving this one, add 3, these cancel. K is less than negative 7 plus 3 is negative 4. K is less than negative 4. So I'm going to go ahead and graph that. Here's negative 4. Open dot, k is less than negative 4. Next one. Or, subtract 5, so you need to get k by itself. Or k is greater than or equal to 3. Or k is greater than or equal to, so that's a solid dot, greater than or equal to 3. So that's what number 9 would look like. So you need to, with these compound inequalities, remember there's two limits. So you're just solving two things, but you're putting them both on one graph. That's all you're doing. All right? Sometimes they're a little more difficult, like this next one we're about to do, where you have to be able to see both parts. So this one starts off and it says 5 is less than 3h plus 2, which is less than or equal to 11. So there's two parts here. There's the left side, which is 5 is less than 3h plus 2. And there's the right side, which is 3h plus 2 is less than or equal to 11. So now it's just like the one above it. So you need to solve both of these. So we're going to subtract 2. Remember the order of operations. So we got 5 minus 2 is 3, less than 3h. I'm going to divide by 3. And I hope you can see that on this video. Let me see. Barely. Okay, so divide by 3, so you end up getting h is greater than 1. Now this one right here, order of operations, subtract 2. 3h is less than or equal to 9, divide by 3. H is less than or equal to 3. Okay, h is greater than 1, so now graphing. Oh, well, I got all kinds of things to erase, I guess. So, let's say this is 0, this is 1, 2, 3, 4, 5. Okay, h is greater than 1. Here's 1. H is greater than 1, go in that direction. But h is less than or equal to 3. Here's 3, close dot, but it's less than or equal to 3. So h is between positive 3 with a closed dot and positive 1 with an open dot. Okay? And again, the open and closed dot, you know, based on those signs. All right, hopefully not too much more to do. I think I'm going to really speed through this last section. Well, maybe not. I don't know. I know you guys need this one more than the other ones. So I'm going to skip this last part because it is this. Okay, it's one and the same. So I'll just do all three of these. All right, so graph each inequality. So notice the difference in these inequalities and the other ones. These have two variables. So you have 2x minus 2y greater than or equal to 8, like that. So we need to still solve for y. All right, so still the order of operations. I'm going to subtract 2x from both sides first. Those cancel. I have a negative 2y greater than or equal to negative 2x plus 8. Notice negative 2x and 8 are separate still. Now I'm going to divide by negative 2. Okay, so y is less than or equal to, signs change directions because of the dividing by a negative, positive x, and then minus 4. All right, so I'm going to rewrite that over here. Y is less than or equal to positive x minus 4. Okay. So to graph this now, realize you start off with your y-intercept, which is the positive 4, or the negative 4. So 1, 2, 3, 4. You put a dot at negative 4. You hopefully realize by now that if x doesn't have a slope in front of it, a visible slope, that your slope is just 1 over 1. It's just 1. Okay? 1 divided by 1 is 1. Now, I write it like this because on the top you have your rise and you have your run as far as slope and plotting points is concerned. So from negative 4, from your y-intercept, you're going to use your slope and go up 1, right 1. Up 1, right 1. Rise 1 on top, run 1 on bottom. Rise 1 on top, run 1 on bottom. Okay? You connect those dots either using, remember, a dashed line or a solid line based on your inequality sign. So this is a solid line because it has the equal sign below it. Solid line. Okay, so we're not done yet. Now we need to shade. Okay? So I talked about to shade, to find out which side of this line you shade on, you pick any point at, just not on the line. Any point would work. I like to use 0, 0 if I can. If 0, 0 is not on the line, I like to use that. Because when you take 0, 0, which has an x and a y in it, when you take 0, 0 and plug it into this inequality, it's either going to be a true or a false statement. If it's a true statement, I'm going to shade on the same side as the 0, 0. If it's a false statement, I'm going to shade on the other side from the 0, 0. So let's plug it in. So 2 times 0 is, well, here's my equation again. 2x minus 2y greater than or equal to 8. So 2x's, 2 times 0 is 0, minus 2y's is 0, greater than or equal to 8. So is 0 greater than 8? No, false statement. So I'm shading on this side. Shade on the other side from that dot because that dot is not a true part of the statement. Let's work 2 more examples, and then I'm done with this video. All right, let's start with 6. 3y greater than 2x minus 3. Okay, to solve for y first. Divide by 3, divide by 3, divide by 3. You need it in slope-intercept form. That's why you're solving for y. So we have y is greater than, notice how I write this fraction, 2/3 x. 2x divided by 3 is the same thing as 2/3 x. I like looking at it this way because I can see the slope easier. There's a rise and a run. So again, you start at negative 1. From negative 1, you rise 2 this time. Rise 2, run 3. 1, 2, 3. Rise 2, 1, 2. Run 1, 2, 3, and I'm kind of running off the grid, but it's still in a straight line. So notice this is strictly greater than. So instead of having the equal sign below it, it doesn't. So we're going to use a dashed line instead of a solid line. If it had the equal sign below it, like this, then we would use a solid line. But because it doesn't, it's dashed. To find out which side of the line we shade on, again, pick a point, preferably 0, 0. Take 0, 0 and plug it into your equation. So let's go ahead and do that. My original equation was 3y greater than 2x minus 3. Plugging 0, 0 into that. So 3 times 0 is 0. Greater than 2 times 0 is 0 minus 3. So is 0 greater than negative 3? That is true. 0 is bigger than negative 3. So look at this dot. Here's the line, so I'm shading on the same side as the dot because it was a true statement. If you back it up on this video and look at the last example, it was a false statement, so we shaded on the other side. Okay, last one. The last one is 2y minus x less than negative 4. So I'm going to start off by adding x. Those cancel. 2y is less than x minus 4. Okay, I'm going to divide by 2. Remember the order of operations. That's why we did this in this order. Divide by 2, divide by 2, divide by 2. Y, the 2's cancel. The y less than, notice how I write x over 2. I realize that that's 1x over 2, so I'm going to write 1 over 2x. It's the same thing. Same sort of thing we just did over here. Minus 4 divided by 2 is 2. And the reason I want to do that is so that I can see my slope easier. So I start at minus 2, which is my y-intercept. Then I rise 1 and I run 2. So rise 1, run 2. Rise 1, run 2. I connect it with a dashed line because there's no equal to sign on here. I shade either above or below. I'm going to use 0, 0 again because I can. All right, so let's erase all this. My original equation was 2y minus x less than negative 4. This is why I like using 0, 0. 2 times 0 is 0, minus 0 is still 0. So 0 is less than negative 4. Is that true? That is not true. Again, so I'm shading on the opposite side from that point. If it was true, I'd be shading where the point is. Okay, guys, I know that's a really long video. If you have questions on anything, you can feel free to ask me in class. Come to tutoring on Monday or Thursday after school. And lastly, just look up some YouTube videos on your own. That's how I taught myself a lot of things in college. So just look up these titles. Okay, see you guys later.